Question number 51. Identify the products A and B respectively in the following reaction. They have given chlorobenzene. First, it is treated with NaOH at 623 Kelvin and 380 pressure, and then H plus to give A. And A is treated with Na2Cr2O7 and H2S4 to give B. So first one is aromatic nucleophilic substitution reaction. So OH minus will attack, and if OH minus is attacking, there will be substitution reaction and there will be formation of phenoxide ion. Now this phenoxide ion with H plus will be converted to phenol. So A in this case is phenol. A is phenol. Now A is treated with Na2Cr2O7H2SO4, which is an oxidizing agent. So it will convert phenol to parabenzoquinone. So it will be converted to this molecule. So correct answer for this question is option number 4. Moving to next question. Question 1 is the boiling point of alcohols and phenols increase with increase in number of carbon atoms. That statement is correct because with increase in number of carbon atoms, there will be more molar mass. More molar mass means more force of attraction. More force of attraction means there will be more boiling point. And the statement 2 is given as the boiling point of alcohol and phenol are higher in comparison to other class of compounds such as ether, haloalkanes, etc. So that is also correct, because in case of alcohols and phenols, there is possibility of formation of hydrogen bonding, which is not there in case of ethers and haloalkanes. That is why the boiling point of alcohols and phenols are higher. So in question 52, both the statements are correct. So correct answer will be option number 3. Moving to next question. Question 53 is they have given a reaction X2Y gas is giving us X2 gas plus half Y2 gas. The equation representing correct relationship between the degree of dissociation X of X2Y with its equilibrium constant Kp is, and we have to assume X to be very small, which is our degree of dissociation. So we can write X2Y gas is giving us X2 gas plus half Y2 gas. Let us say T is equal to 0, we have 1 mole. At T is equal to T equilibrium, they are saying degree of dissociation is X, so it will be 1 minus X. This will be X, this will be X by 2. So if we see total number of moles at equilibrium, so it will be 1 minus X, that is moles of X2Y, plus X, which is moles of X2, plus X by 2, which is moles of Y2. So total number of moles at equilibrium is 1 upon 1 plus X by 2. Now expression of Kp will be equal to partial pressure of X2 into partial pressure of Y2 raised to the power 1 by 2 upon partial pressure of X2Y. Now we know partial pressure is equal to mole fraction into total pressure. So partial pressure of X2 will be equal to X upon 1 plus X by 2 into total pressure, I am assuming it to be P, times partial pressure of Y2 will be equal to X by 2 upon 1 plus X by 2 into P raised to the power 1 by 2 upon partial pressure of X2Y will be equal to 1 minus X upon 1 plus X by 2 times P raised to the power 1. Now this P and P is cancelled out. This 1 plus X by 2 and 1 plus X by 2 is cancelled out. Now as they are saying that X is very small, so we can write 1 plus X by 2 will be approximately equal to 1, and 1 minus X is also approximately equal to 1. So we will get Kp is equal to X into X by 2 to the power 1 by 2 into P to the power 1 by 2. So we can write Kp is equal to X to the power 3 by 2 into P to the power 1 by 2 upon 2 to the power 1 by 2. If we square both sides, we will get Kp square is equal to X cube into P upon 2. So we will get X cube is equal to 2 times Kp square upon P. So X will be equal to cube root of 2 times Kp square divided by P. So correct answer for this question is option 1. Moving to next question. Given below are the atomic numbers of some group 14 elements. The atomic number of the element with the lowest melting point is. So they are talking about group 14 elements, which means carbon, silicon, germanium, tin and lead. Out of these, the lowest melting point will be of tin. So, atomic number 6 is carbon, atomic number 14 is silicon, atomic number 50 is tin, atomic number 82 is lead. So, correct answer for this question is option number 1, that is 50. Next question. Question 55. Given below are two statements about X-ray spectra of elements. Statement 1 says a plot of root mu, that is frequency of X-rays emitted versus atomic mass, is a straight line. That is incorrect. A plot of root mu versus atomic number will be a straight line. We know root mu is proportional to Z, which is atomic number. Statement 2 given is a plot of mu versus atomic number is a straight line. That is also incorrect. It should be root mu versus Z will be a straight line. So, both statement 1 and statement 2 is wrong. So, correct answer for this question is option number 2. Moving to next question. Question 56. Which of the following graph most appropriately represents a zero order reaction? They have given reactant concentration versus time and they have given rate versus time. So, for zero order reaction we know AT is equal to A naught minus KT, where AT is the concentration at time t, A naught is initial concentration, K is the rate constant and T is the time. So, the correct graph according to this will be graph number 1. If I want to draw rate versus time graph, so rate is equal to K into concentration of A to the power 0, which means it will be a straight line. So, if you draw rate versus concentration graph, then it will be a straight line. Moving to next question, question 57. pH of water is 7 at 25 degree centigrade. If water is heated to 80 degree centigrade, its pH will. So, we know pH for water is equal to half of pKw. Now, at 25 degree centigrade, pKw is equal to 14. That is why pH of water at room temperature is half of 14, which is 7. Now, when it is heated to 80 degrees centigrade, so we know at 80 degrees centigrade pKw will be reduced and it is approximately equal to 13. So, at this temperature pH will be equal to 13 by 2, which is equal to 6.5. So, we should know that if temperature is increased, then pKw will decrease. So, pH of the solution will be 6.5. So, pH will decrease. So, correct answer is option 2. Moving to next question. When a non-volatile solute is added to the solvent, the vapor pressure of the solvent decreases by 10 mm of Hg. The mole fraction of the solute in the solution is 0.2. So, they have given mole fraction of solute is 0.2, which means mole fraction of solvent will be equal to 0.8 and decrease in pressure is by 10 mm. What would be the mole fraction of solvent if decrease in vapor pressure is 20 mm Hg? It means vapor pressure decrease will be doubled if the amount of non-volatile solute is doubled. It means the mole fraction of solute should be equal to 0.4, and if mole fraction of solute is 0.4, in that case mole fraction of solvent will be equal to 1 minus 0.4, which is equal to 0.6. So, correct answer for this question is option 4, that is 0.6. Moving to next question, they have given isomers of C10H14 and they are asking what is the ozonolysis product of the reaction. So, what we can do is we can break the bonds like this and we can add double bond O, double bond O, double bond O and double bond O over here. Same way, so if I write the product, so it will be equal to, if I write the product of A, so it will look something like this. So, double bond O over here, double bond O, then we will have double bond O on this carbon and double bond O on this carbon. This is for A. If I write for B, so again we have to break the double bond and we have to add double bond O. I hope all of you are aware of the ozonolysis reaction, in which we have to form the ozonide first and then it is converted to this. So, this is option B. Option C will be double bond O, then double bond O, double bond O and double bond O. That is for option number C. And option D, if I write, so it will be like this: double bond O, double bond O, double bond O, double bond O. So, these are the 4 products of the reaction. So, if we match with the given options, A will match with, so we have CHO, then CH2, CH2 and CHO. So, we can see option number 3 CHO, then CH2, CH2, C double bond O, then we have CH2, C with CH3, so C with CH3, then CH2. So, A is option number 3. So, this option is eliminated, this is eliminated. Next, we have to check for B. If we see B will be either 2 or 4. So, option B is, we have CH3, then C double bond O. So, CH3, C double bond O, then CH2, then again C double bond O, then we have 4 carbons, 1, 2, 3, 4. So, 4 carbon over here, then CO and CHO. So, CO and CHO. So, option B is 4. So, correct answer for this question has to be option number 4. Moving to next question. They are saying question number 60, consider a binary solution of 2 volatile liquid components 1 and 2. X1 and Y1 are the mole fraction of component 1 in liquid and vapor phase respectively. The slope and intercept of the linear plot of 1 upon X1 versus 1 upon Y1 are given respectively as. Okay, so we know that PT is equal to, according to Raoult's law, it is X1 into P1 naught plus X2 into P2 naught, or Chi1 P1 naught plus Chi2 P2 naught. We also know that P1 will be equal to Y1 into PT. This is as per Dalton's law. P1 is equal to Y1 into PT. P1 we can write as Chi1 into P1 naught, that is equal to Y1 into PT. In place of PT, I can write as Chi1 P1 naught plus Chi2 can be written as 1 minus Chi1 into P2 naught. So, if I open this bracket, we will get Chi1 P1 naught is equal to Chi1 Y1 P1 naught plus Y1 P2 naught minus Chi1 Y1 P2 naught. If we rearrange, we will get Chi1 P1 naught is equal to Y1 P2 naught plus Chi1 Y1 P1 naught minus P2 naught. Now, we have to divide it by Chi1 and Y1. Divide by Chi1 times Y1. So, it will become P1 naught upon Y1, that is equal to P2 naught upon Chi1 plus P1 naught minus P2 naught. Now, we want 1 upon X1 versus 1 upon Y1. So, we will rearrange this equation to P2 naught upon Chi1 is equal to P1 naught upon Y1 plus P2 naught minus P1 naught. So, if we divide by P2 naught, we will get 1 upon Chi1 is equal to P1 naught upon P2 naught times 1 upon Y1 naught plus P2 naught minus P1 naught upon P2 naught. So, this will be our slope and this will be our Y intercept, slope and intercept. So, correct answer will be slope is P1 naught upon P2 naught and intercept is P2 naught minus P1 naught upon P2 naught. So, correct answer is option 1. Moving to next question. The ascending order of relative rate of solvolysis of the following compound is. So, solvolysis will follow SN1 mechanism. In SN1 mechanism, reactivity will depend on stability of carbocation. Reactivity is directly proportional to stability of carbocation. So, in the first case, in case of A, the carbocation formed is this. In case of B, the carbocation formed is this. In case of C, the carbocation formed is this, and in case of D, the carbocation will be this. Now, in case of C, we can see that it is getting stabilized by resonance by two benzene ring. There are two plus M groups which are stabilizing this. In case of B, there is one plus M group which will stabilize, plus there will be hyperconjugation. In this case, it is stabilized by hyperconjugation. This also is stabilized by hyperconjugation. So, we know resonance will dominate over hyperconjugation. That is why most stable will be C. After that, it will be B. Now, between A and D, we have to check in which case we have more hyperconjugation. So, in case of A, there are 7 alpha hydrogens, 2 over here, 2 over here and 3 on this. In case of D, there are 3 plus 1, total 4 alpha hydrogen. So, we know more alpha hydrogen, more will be hyperconjugation, and more the hyperconjugation, more will be stability. That is why A is more stable than D. So, correct answer is C more than B, more than A, more than D. So, correct answer is option number 3. Moving to next question. They have given two lists and we have to find the correct match. So, bronze is an alloy of copper and tin. So, A is 4. Brass is an alloy of copper and zinc. So, B is 3. UK silver coin is an example of alloy of copper and nickel. So, it is 1 and stainless steel will be 2. So, correct answer is A is 4, B is 3, C is 1, D is 2. So, 4, 3, 1, 2. Correct answer is option number 1. Moving to next question. They have given two statements again. Consider the following reaction. Ketone plus H2O is given. Statement 1 is, in the case of formaldehyde, K is about 2280. Due to small substituents, hydration is faster. This statement is absolutely correct because of a small size, less hindrance, rate will be more. Statement 2, in case of tricolored aldehyde, K is about 2000 due to minus Fi effect of Cl. That is also correct. Cl is electron withdrawing group, because of that the reactivity will increase. So, both statements are correct. So, correct answer for this is option number 3. Question 64. The effect of temperature on spontaneity of reaction are represented as delta H, delta S and temperature they have mentioned. So, we know delta G is equal to delta H minus T delta S. For a reaction to be spontaneous, for a spontaneous reaction, delta G should be negative, and for non-spontaneous reaction, delta G should be positive. Now, if you take first statement, delta H is positive and delta S is negative. So, if delta H is positive and delta S is negative, delta G will always be positive. And if delta G is positive, it means it is always non-spontaneous. So, statement A is correct. Okay, one more important point is they are asking the incorrect combination. So, statement A is correct. If you see option number D, they are saying delta H is negative and delta S is positive. So, in this case, delta H is negative and delta S is positive. So, this delta G will always be negative. And if delta G is negative, it means this is always spontaneous. So, option D is also correct. Now, if you see option B, they are saying delta H is positive and delta S is also positive. So, for this reaction to be spontaneous, or for this reaction, if the delta G has to be negative, then the value of T, it should be high. So, if it is high temperature, then only it will be spontaneous. If it is low temperature, then it will be non-spontaneous. So, they have given at low temperature it is spontaneous. So, this is incorrect. And if we see option option C, in case of option C, they are saying delta H is negative, delta S is also negative. So, for this reaction to be spontaneous, temperature should be low. If temperature is low, then only it will be spontaneous. But over here they are saying that it is non-spontaneous at low temperature. So, B and C are incorrect in this. So, correct answer will be option 2, that is B and C. Moving to next question. Statement 1 is, for a given shell, the total number of allowed orbitals is given by n square. That is a fact, it is a correct statement. For any subshell, the spatial orientation, means they are talking about magnetic quantum number of the orbitals, is given by minus L to plus L values including 0. That is also a correct statement. So, both statement 1 and statement 2 is correct. So, the correct answer for this question is option number 4. Moving to next question. Identify the coordination complex in which the central metal ion has D4 configuration. So, they have given 5 complexes or 5 compounds. We have to find in which case central metal ion is having D4 configuration. So, let us start with FeO4 2 negative. So, if I am having FeO4 2 negative, in this iron is present in plus 6 oxidation state. In plus 6 oxidation state, what will be its electronic configuration, that you have to find. So, we know iron configuration is 3d6 4s2. If we remove 6 electrons from this, it will be 3d2. So, A is eliminated. Next is MnCN6 3 negative. So, in this case manganese is present in plus 3 oxidation state. Now, we know Mn in ground state is 3d5 4s2. If we remove 3 electrons from manganese, it will become 3d4. So, yes, in this case manganese is present in D4 configuration. Third one is FeCN6 3 negative. In this iron is present in plus 3 oxidation state. We know configuration of iron is 3d6 4s2. If we remove 3 electrons from this, it will become 3d5. So, Fe plus 3 in FeCN6 3 negative is having 3d5 configuration. Next one is complex in which chromium is present in plus 2 oxidation state. Now, we know chromium configuration is 3d5 4s1. If we remove 2 electrons from this, it will become 3d4. So, yes, in this case also the central metal ion is having D4 configuration. And last one is nickel plus 4. Now, we know nickel in the ground state is having 3d8 4s2 configuration. Now, if you remove 4 electrons from this, it will have 3d6 configuration. So, the correct answer for this is B and D. So, correct answer is option number 4. Moving to next question. The alpha helix and beta pleated sheet structure of protein are associated with it is again a factual question. It is associated with the secondary structure. Moving to next question. The standard electrode potential for a few half cell are mentioned below. Which one of the following cells gives the most negative value of delta G naught? So, we know delta G naught is equal to minus of NF E naught cell. So, for finding delta G naught, we have to find the value of E naught cell. So, we will calculate for all the cells. First one cell will be Cu plus 2Ag plus will give Cu plus 2 plus 2Ag. E naught for this cell will be minus 0.34 Cu is getting converted to Cu plus 2, so it is minus 0.34, plus Ag plus is getting converted to Ag, so it is 0.80. So that will be 0.46 volt, and delta G naught is equal to minus of 2F into 0.46. So it is approximately minus 0.92 Faraday. Next equation will be Ag, 2Ag plus Mg plus 2 is becoming 2Ag plus magnesium. E naught for this, Ag is getting converted to Ag plus, it is minus 0.80, plus Mg plus 2 is getting converted to Mg, so it is minus 2.37. So it will be equal to minus 3.17. So delta G naught will be equal to minus of 2F into minus 3.17. So this is going to be a positive quantity. Third one is Zn plus Mg plus 2 is becoming Zn plus 2 plus magnesium. E naught for this reaction will be equal to 0.76 plus Mg plus 2 to Mg is minus 2.37. So this quantity is coming out to be negative. So delta G naught in this case will also be a positive quantity. And fourth reaction is Zn plus 2Ag plus will give you Zn plus 2 plus 2Ag. E naught for this is going to be Zn2 Zn plus 2 is 0.76 plus Ag plus 2 Ag is 0.80. So this is going to be 1.56 volt. So delta G naught will be equal to minus 2F into 1.56. So that will be equal to minus of 3.12F. So most negative is coming out in option 4. So correct answer for this question is option 4. Moving to next question. Identify A, B and C in the given below reaction sequence. A with HNO3 gets lead nitrate, which on treatment with H2SO4 gives B, and B on treatment with ammonium acetate, acetic acid and K2CrO4 gives a yellow precipitate. So we have to find which one is A, B and C. So A, if it is lead sulphide, A is PBS. PBS when it is treated with HNO3, it will be converted to lead nitrate. Lead nitrate when it is treated with H2SO4, this will be converted to lead sulphate, and lead sulphate on further treatment with ammonium acetate, acetic acid and K2CrO4 will be converted to lead chromate, and this lead chromate which is formed will have yellow precipitate. So A is PBS, B is PbSO4 and C is PbCrO4. So correct answer for this question is option number 2. Moving to next question. K2Cr2O7 in presence of KOH is giving A, which in presence of H2S4 is giving B. So we know K2Cr2O7, or we can write like this, Cr2O7 2 negative, Cr2O7 2 negative in basic medium will be converted to CrO4 2 negative, and CrO4 2 negative again in acetic medium will be converted to Cr2O7 2 negative. So this is going to be A and this is going to be B. So correct answer for this question is option 3, that A is K2CrO4 and B is K2Cr2O7. Moving to next question, we have a sequence of reaction. So we have to find total number of sp3 hybridized carbon atoms in the major product C which is formed. So we can write this reaction, we have NH2 and at para position we have OET attached. First it is treated with NaNO2HCl at 0 to 5 degrees centigrade. So we know it is a diazotization reaction. So in case of diazotization reaction, diazonium ion will be formed over here. Now this compound is treated with phenol. This is treated with phenol. So we know with phenol a coupling reaction will happen and it will be converted to this O, Et and double bond N, OH. This is formed. This is compound is B. This compound is treated with NaOH. So, we know NaOH is a base which will extract this acidic hydrogen, and then it is treated with CH3CH2Br. So, first an anion will be formed and this anion will react with CH3CH2Br. So, SN2 reaction will take place, this leaving group will depart. So, it will be converted to O, Et and double bond N, O and again Et. So, this is compound C. So, they are asking total number of sp3 hybridized carbon atoms in the major product C. So, there are 2 sp3 hybridized atoms over here and there are 2 sp3 hybridized atoms over here. So, in total there will be 4 sp3 hybridized atoms. Moving to next question. Next question is 0.01 mole of an organic compound X containing 10% hydrogen on complete combustion produced 0.9 gram H2O. What is molar mass of X in gram per mole? So, basically they are saying we have, let us see, OC organic compound is undergoing combustion. So, it's treated with O2. So, in general it produces CO2 and H2O. Now, they are saying 0.9 gram of H2O is produced. So, we can find the moles of H2O which is formed. So, moles of H2O will be 0.9 upon 18. So, we can write it as 1 by 20. So, 1 by 20 moles of water is formed. Now, we know moles of hydrogen in water and moles of hydrogen in organic compound are going to be same. So, we can find moles of hydrogen atoms. So, moles of hydrogen atom will be 2 times the moles of H2 molecule. So, it is 2 times 1 by 20. So, it is 1 by 10 moles. Now, weight of hydrogen atom, we know each atom weight is 1 gram per mole. So, it will be 1 by 10 into 1 grams, which is 0.1 gram. Let us say molar mass of organic compound is capital M. So, weight of organic compound which we have taken 0.1 mole. So, weight of organic compound will be equal to 0.01 times M, and they are saying that weight of hydrogen is 10% of this. So, we can write weight of hydrogen will be equal to 10 by 100 into 0.01 M, and this is equal to 0.1, which we have calculated over here. So, if we simplify this, we will get M equal to 100 gram per mole. So, answer for this question is 100. Clear? Okay. Moving to next question. Next question is when 81 gram of aluminum is allowed to react with 128 gram of oxygen gas, the mass of aluminum oxide produced in grams is. So, we know aluminum plus O2 will give you Al2O3. So, if you balance this reaction, we will get 4Al plus 3O2 will give 2Al2O3. Now, we have 81 gram of aluminum and 128 gram of oxygen gas. So, moles of aluminum will be equal to 81 divided by 27 which is equal to 3 moles, and moles of O2 will be equal to 128 divided by 32 which is equal to 4 moles. Now, we have to find limiting reagent. So, for limiting reagent we find this ratio moles upon stoichiometric coefficient. So, it is 3 by 4, this is 4 by 3. So, this ratio is less, it means aluminum is our limiting reagent. Now, 4 mole will produce 2 moles of Al2O3. So, 3 moles of aluminum will produce 1.5 moles of Al2O3. Now molar mass of Al2O3 will be equal to 2 times 27, which is 54, plus 3 times 16, which is 48. So 8 plus 4 12, 5 plus 5 10, 102 gram per mole. So weight of Al2O3 will be equal to 1.5 into 102 gram. 1.5 times 102 gram, which is going to be approximately 153 grams. Next, so answer for this question is 153 gram. Moving to next question, they are saying a compound X absorbs 2 moles of hydrogen and X upon oxidation with KMnO4 H plus, and it gives these 3 molecules on oxidation. So you have to find the total number of sigma bonds present in the compound X is. So X should be CH3, C, double bond C, CH3, CH3, H, C, H2, CH2, CH, double bond CH and CH3. If I am having this compound, then this only on treatment with MnO4H plus will give this, and we can see that there are 2 double bonds. It means it will absorb 2 moles of hydrogen. Now they are asking how many sigma bonds are present in this compound X. So we can count now. Total number of sigma bonds in this compound is going to be 27. So total 27 sigma bonds are present. So answer for this question is 27. Moving to the last question, the bond dissociation enthalpy of X2 calculated from the given data is, we have to mark the nearest integer. So they have given M plus X negative solid is becoming M plus gas and X minus gas. Delta H naught lattice energy is given, then M solid sublimation energy is given. So we can use bond Haber cycle for this. We can write M solid plus half X2 gas is giving us M plus X minus. Delta H for this reaction is equal to minus 400. Now M solid is becoming M gas. For this they have given 100 kilojoule per mole energy is required. M gas is becoming M plus gas, and for this they have given 500 kilojoule per mole energy is released. Now half X2 is becoming X gas. The energy which is required for this will be X divided by 2, where X I am assuming as bond dissociation, X is bond dissociation enthalpy, and this X is becoming X minus. In this process they are saying that 300 kilojoule per mole energy is released, and this M plus and X minus, they are attracting each other and is getting converted to Mx. In this process 800 kilojoule per mole energy is released. So I can write the equation will be 100 plus 500 plus X by 2 plus minus 300 plus minus 800 should be equal to minus 400. So we will get 600 minus 1100 plus X by 2, that is equal to minus 400. So we will get minus 500 plus X by 2 is equal to minus 400, which means X by 2 is 100. So X, which is our bond dissociation energy, that will be 200 kilojoule per mole. So correct answer for this question is 200 kilojoule per mole. So these many questions were there in shift 2 of 23rd Jan JEE Mains. Thank you.